Welcome to our geology tour of Central Zuni Mountains in western New Mexico. We went up there to look at some of the structures of the mountains. First, we stopped at the chain of craters where we could view off to the south, the crater chain heading off toward Globe, Arizona to the southwest, through which lava flowed, being a fault zone that brought the forces that uplifted the Zunis. This is Cerro Bandera, one of the closest craters to our site, about 2 or so million years old. The San Andreas limestone and the Glorieta sandstone are the rocks that top the sedimentary layer in this region. This is the limestone, which we'll see more of, and underneath it is the Glorieta sandstone, a dune sandstone with some fresh water running through. On the other side of the ridge is the Oso Ridge ash fall field, and coming out of this ash fall is a smaller lava flow which flowed off toward the east. You can see it here on top of the hill of ash. And this lava flowed down, of course, the lowest point, River Valley, solidified, and then the sediments on either bank of the river valley eroded away, leaving the lava today as a ridge rather than a valley fill. This is an example of the cinder that we see, and here's the flow itself, maybe a mile or so down the road. It went all the way down to the southern side of the Zuni, southeastern side. Another volcano in the region is the Paxton Springs cone, which had a north and a south flow. The north flow, which went to Grants, is 21,000 years old, and the south flow, 15,000 years old, went down and mixed with the Oso Ridge flow. The gneissic granite is showing here, exposed. And here are some pieces of the granite itself with some areas of aplitic veins that have filled fractures in the rock. The gneissic granite is about, 1.4 billion years ago, I think is when it solidified. Here's some more highly metamorphosed of the granite and some less metamorphosed of the granite. The granite was emplaced in Precambrian times and then underwent a lot of metamorphism while it was deeply buried during the Laramide uplift 50 million years ago. Here's some more specimens of the gneissic granite, which is the basic granite of the core of the Zuni Mountains. Now, in certain areas on top of the granite is this fossiliferous limestone, which is the oldest sedimentary layer in the Zunis. This is probably Pennsylvanian limestone, which was formed at the bottom of a warm, limey ocean, kind of like the Bahamas. And at the bottom, there are many, many fossils embedded in the solidified sediments, now limestone. Beyond that is more granite, and in this area we found a bunch of fault zones filled with quartz veins. And you can see some, maybe some crystals in there. Okay, here's a blob of quartz that just kind of is on its own. Now on the south side, there is a sedimentary mesa, but this is the sedimentary mesa on the north side of the granite core of the Zunis. And this is basically all the Permian rocks that are exposed in the sediments surrounding the Zuni Mountains, including at the bottom the orangey sandstones, and then as you rise a little higher, you find a couple of gypsum layers, 3 basic gypsum layers in the Yezo Formation. And then at the top of the Yezo, you have that dark brown mud, or red-brown mud, which has turned into shale. Above that is a whitish layer of Glorieta sandstone, and topping it off is the San Andreas limestone. So here about a 600-foot cliff, and quite a bit of rock there, the whole Permian section. Off to the left, you can see the granite rising out of the granite core of the Zuni Mountains. At some point, we're going to take a look to the right, and we're going to look down Zuni Canyon, which you can see is covered with a lava flow at the base, and then over to the mesa on the other side to the right. And then finally, we'll be looking down Bonita Canyon, which is a fault zone between the granite, as you see here too, between the granite and the sedimentary layer. There's a fault system running along that boundary, and it's the basically the separation of the sedimentary rocks of the igneous rocks. Here you see Zuni Canyon headed toward Mount Taylor and Grants, and the other slope of the North Sedimentary Mesa. The mesa breaks off right about where the road is, and farther to the right you can see the slow sloping rise of the granite core of the Zuni Mountains. So this road pretty much follows the fault zone between the sedimentary layers on the left, which are tilted at about 4 to 5 degrees down to the left, and the uplifted core, granite core of the Zunis off to the right. Now just below in the foreground is a lava flow that came from the right through a canyon from the Paxton Springs cone, which we saw just moments ago. And at this point, the lava pooled into an area, as you can see, and then flowed off to the left, again down Zuni Canyon, all the way to Grants, where at the mouth of the Zuni Canyon in Grants, there's a big pool of lava that came from this flow. So after this scene, we're going to head back up the road off to the left, not down the canyon here, but even farther to the left along the fault zone into the high granite peaks of the Zuni Mountains, where the highest elevations occur. Here we're roughly 7,500 or so elevation, and we'll go on up to almost 9,500. Okay, again, Zuni Canyon with a lava flow that you can see going down, and the forest road heading out through the canyon, exiting in the town of Grants. Again, the Permian section is pretty much illustrated here in this cliff. And so we're going to go down and then off to the left into the high peaks. Okay, here we are in a valley between two thrust sheets. One of the thrust sheets is there on the horizon. You can see this is the upthrown side. This valley is basically an alluvial valley between that thrust sheet off to the right, and as we turn slowly to the left, you'll see the other thrust sheet, which has been pushed upward by subterranean forces 50 million years ago or so into these giant curve-shaped thrust fault sheets. And in the distance you can see Mount Taylor beyond where Grants lies. And over here, following now, you can see these peaks point out the edge of the highest thrust fault sheet in the Zunis. The highest peak right there is Mount Sedgwick, which is the highest point in the Zuni Mountains, 9,256 feet. The other side of those peaks drops off pretty steeply because this thrust sheet is very gently sloped on this side and much steeply sloped on the other side. Of course, thrust fault sheets are chunks of the earth that are pushed up and over the earth in front of them. And this is what gives the Zunis such a high elevation here, because it's the top of the thrust sheet, the top edge. And this area is deeply covered in snow in the wintertime. these roads are pretty inaccessible in the winter unless you've got a snowmobile or are willing to go skiing. The cliffs in the far horizon are part of the uplift where the Cretaceous uplift, also uplifted originally by the Zuni uplift and tilted. Okay, now we turn toward the northwest and we're looking toward Gallup. And if you look carefully, you can see on the horizon the north-facing sedimentary layer of the Zunis. And then as the camera moves to the left, you'll see the central granite core of the Zunis. And on the other side of it, the southern sedimentary layer. This is now looking almost due west here. Okay, and then in the close distance, you can see the edge of the thrust sheet to the south of where we are. So to the north, we had the thrust sheet, which was higher, that it contained Mount Sedgwick. This thrust sheet is high. It has a steep edge, but not as tall as the one behind me. All right, time for lunch. Watch the thunderstorms. This is a alluvial meadow high up in the mountains around 8,700 feet. And then on the way out, we pass this Quartz Mountain or Quartz Ridge. And basically what it is a very elongate ridge littered with these quartz pieces. And in fact, it's made of quartz. Most likely this is a product of the differentiation or the separation by weight of minerals while deeply buried in a liquid state, or semi-liquid state. And the quartz, being the lightest, floated up to the top of the bubble. And the granite and iron-rich products sank to the bottom of the bubble. And so when rock separates by this method, it's called differentiation. And it's basically becoming different by virtue of its density. So this quartz is very amazing in size and purity. It's got a lot of whiteness to it, so there's a little bit of impurity, but it's mostly white quartz. Sometimes you can find valuable minerals in this stuff, but it doesn't seem to be true in the Zunis. About the best use of the land is for lumbering, and you can see there's been some of that going on too. Okay, here come your two hosts. I hope you had a good time watching this, and maybe we'll do it again. From the south side of the granite core of the Zuni Mountains, the thrust ridges look like this. This is the southernmost ridge, and on the other side of the valley is the Sedimentary Mesa coming up from the south side of the mountains. Here at Cold Spring, we say goodbye to all of our followers, either virtual or actual.